In the last video, we have talked about maximum and minimum. And in this video, I will introduce the concept of supremum and infimum. And we first define what supremum and infimum mean. Let L be a real number. We call L a supremum of S if L is the least upper bound. And it is equivalent to two statements. First, L should be greater than or equal to x for all x inside S. And the second is that if L prime is greater than or equal to x for all x inside S, then L is smaller than or equal to L prime. What the first statement is telling us is that L is an upper bound. And the second statement tells us that it is the least upper bound. Similarly, we can define what infimum is. An infimum is the greatest lower bound, which means L is smaller than or equal to x for all x inside S, and if L prime is smaller than or equal to x for all x inside S, then L is greater than or equal to L prime. We write the supremum as sup S and the infimum as inf F. And here is a remark about supremum and infimum. If the maximum of a set exists, then the maximum is indeed the supremum of that set. How to prove it? Well, first of all, by the definition of maximum, we have mu greater than or equal to x for all x inside S. Here, mu is our maximum. Also, by the definition of maximum, we also know that mu should be lying inside S. So then we assume that there exists some mu prime such that mu prime is a supremum of S. By the definition of supremum, we have mu prime smaller than or equal to mu, and mu prime greater than or equal to x for all x inside S. The first statement tells us that mu prime is the least upper bound, and the second statement is telling us that mu prime is the upper bound. Now, we know that mu is lying inside S, so we can replace this x by mu. And so we obtain that mu prime is greater than or equal to mu. And therefore, we gather these two information and we get mu prime is smaller than or equal to mu, and mu prime is greater than or equal to mu. And that means mu prime is equal to mu. After finishing this, we have another theorem. Another theorem saying that suppose supremum of S exists, then infimum of negative S also exists, and infimum of negative S is equal to negative of supremum of S. Why is this theorem important? It's because when we're studying supremum and infimum, if we can understand what the properties of supremum are, we can extend this property to infimum as well. So let's start proving it. Well, first of all, the proof is we let L equal to supremum of S. Our first claim is saying that negative L is a lower bound of negative S. And how can we prove it? Well, first of all, if L is the supremum of S, then L is an upper bound of S. And hence, L is greater than or equal to x for all x inside S. Taking negative sign to both sides, we have negative L is smaller than or equal to negative x for all x inside S. Now, note that x inside S is equivalent to saying that negative x is inside negative S, and so there exists some y inside S such that negative y is equal to x. and this is equivalent to saying that y is equal to negative x. So we have negative L smaller than or equal to y for all y inside negative s. And therefore, we have negative L is a lower bound of negative s. And to prove it is a infimum, we have to prove that it is a greatest lower bound, which is equivalent to saying that if L prime is another lower bound of negative s, then L prime should be smaller than or equal to negative L. And how can we do so? Well, since L prime is the lower bound of negative s, we know that negative L is an upper bound of s by our previous video. Now, L equal to supremum of s. That means L should be smaller than or equal to L prime by the definition of supremum. And taking negative side to both sides, we get negative L is greater than or equal to L prime. And this is the same thing. This is the same thing as the above mentioned statement. So the infimum of negative s is equal to negative L, and L is equal to supremum of s, so it is equal to negative of supremum of s. And that's it about supremum. And in the next video, we will continue on supremum and infimum, as there are further properties about supremum and infimum. See you in the next video.